Hello and welcome to today's ACM TechTalk. This webcast is part of the ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals and students. I am Angelica Loduca, a researcher at the Institute of Informatics and Telematics of the National Research Council in Italy, and an external professor of data journalism at the University of Pisa. My research interests include data engineering, data science, data journalism, and web applications. I'm also the author of Comet for Data Science, published by PACT, co-author of the forthcoming book Learning and Operating Presto, published by O'Reilly Media, and author of the forthcoming book Data Storytelling with Python, Altair, and Generative AI, published by Manning Publication. For those of you who may be not unfamiliar with ACM or what it has to offer, here is more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. You can see some of the highlights on your screen. ACM provides access to the ACM Digital Library, the world's most comprehensive database computer literature, leading publications and global conferences that draw to experts on a broad spectrum of computing topics, support for education and research, including curriculum development, teacher training, the ACM Turing and ACM Prize and Computing Awards, and the ACM Code of Ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. Before we get started, we'd like to quickly mention a few housekeeping items shown on the slide in front of you. If you have questions at any time, please type them in using Zoom's Q&A button. We organize the questions as Nicole and Michael speak and try to get as many as possible. If you like a question asked by others, you can upvote it. This session is being recorded and will be archived. You'll receive an email notification when it becomes available, and check learning.acm.org for updates on these and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill it to help us improve our TechTalk. Today's presentation is Ethical and Responsible Large Language Models, Challenges and Best Practice with Nicole Koningstein and Michael Noguer y Alonso. Nicole Koningstein is a distinguished data scientist and quantitative researcher currently working as Chief Data Scientist and Head of AI and Quantitative Research at Wyden Capital. Alongside her role in this organization, she serves as an AI consultant across diverse industries, leading workshops and guiding companies from the conceptual stages of AI implementation through the final deployment. As a guest lecturer, Nicole shares her expertise in Python, machine learning, and deep learning at various universities. She is a regular speaker at renewed AI and data science conferences where she conducts workshops and educational sessions. In addition, she is an influential voice in the data science community, regularly reviewing books in her field and offering her insights and critiques. Nicole is also the author of the well-received online course, Math for Machine Learning, published by Manning Publications, and the author of the forthcoming book, Transformers in Action, published by Manning Publications. Michael Noguer y Alonso is a seasoned financial professional and academic with more than 30 years of experience in the industry. He is the founder of the Artificial Intelligence Finance Institute and head of development at Global AI. His career includes roles such as executive director at the UBS AG and CEO for Andbank. He has served on the European Investment Committee for a decade. He is on the advisory board of FDP Institute and CFANEY. Michael is also an academic teaching AI, big data, and fintech at institutions like New York University, Current Institute, Columbia University, and the SAID. He pioneered his first fintech and big data course at the London Business School in 2017. He is the author of 10 papers on artificial intelligence. He holds an MBA and degree in business administration from ESAID, a PhD in quantitative finance from UNED, and other prestigious certifications. His research interests span asset allocation, machine learning, algorithmic trading, and fintech. Nicole and Michael, without further ado, take it away.
Thank you, Angelica, for the kind introduction for housekeeping items. Let me share my screen and just give me a short hint if you can see the presentation of one side and the code of the other side.
We do, yes.
Okay, great, thanks. All right, so let me start the presentation then. So yeah, like Angelica said, that today's talk is about ethical and responsible large language models with the challenges and the best practices. So that are the topics, the main challenges we are looking at. So we are looking about transparency and explainability, how you can control generated content. And as a last part, we look at bias mitigation. And just shortly, housekeeping from my side. So the slides will be shared with you for today's presentation, and make sure you look up the code. So there are some code examples. So one is specifically for the TechTalk for today with all the code examples and a bit more of them. And also there's a link to my repository for the book I'm currently writing, and there will be a chapter exclusive for responsible AI for large language models. All right, let me go into transparency and explainability. So what is the importance of transparency and explainability? So of course, we need that for trust and accountability, and we need that for legal and ethical considerations. And of course, we want also facilitate user understanding with that. And how can we achieve that? So we can use attention visualization to do that. And with visualization, the focus of attention in transformer models, we can improve the understanding of the model decision-making process. So because the large language models are transformer-based, and so we have the attention mechanism, and that is a great way of looking deeper inside in the decision-making process of those models. And there's a great library called Captum, and you can use that to really go deep into the architecture of that model. And that's an open source library. It's developed by Meta, and it's mostly for PyTorch models. And here's an example how you can use that. So here we visualize the attribution matrices. And the attribution matrices are the query and the key matrices of that attention modeling of that large language model. And what we currently see here is a question answering task. And we have the start and the end position, what we are looking at. And here for the slide, what we are seeing here with our model is that the model focuses more on the questioning side when we are forecasting the start position, more specifically on the tokens that are that and important. And it also has a modest emphasis on the token sequence to us in the next slide, so on the answering side. And in contrast, our model focuses more on the text side and has a rather high attribution on the final end position token types when predicting the end position. And another fact, what we can do and look deeper inside is we can visualize the distribution of the attribution per layer for specific tokens. And here's just an example for the token kinds from the previous task, so from that question answering task for the start position. And what we can see here with the box plot diagram on the current slide, we see the presence of outliers, especially in the first 4 layers and in the 8th layer. And we can observe that the start position prediction interquantile range slowly decreases as we go deeper into the layer and finally is then diminishing. And having those box plots, they really provide a compact and informative way of visualizing the distribution of those attribution across different layers. And that makes it easier to identify trends or patterns or potential anomalies in the model's behavior. And here's another example for the attribution, how you can visualize it and gain more information. So you can visualize the attribution entropy based on the Shannon entropy. And with that, you can gain insight which features are contributing the most to the predictions of the model and which features are providing less information or contributing less or more to the overall uncertainty of the model. And specifically here in this example, entropy doesn't change much from layer to layer, but in general, it can give us an intuition about the distributional characteristics of the attributions in each layer, especially then comparing it across multiple tokens. And here is then a way of visualizing the attention overall. So here we are visualizing the attention matrix per selected layer. And here I show just an excerpt of layer 1. If you look into the provided notebooks in the repository, you will see that there are all the layers of that model I analyze here. And you can see how the model progresses throughout that task. And with that token relationships, we can examine how the attention scores between tokens within specific layer can change, and that gives us insights into the models considered related or relevant to one another at that stage of that processing step. And this can help you understand how the model captures synthetic or semantic dependencies between tokens within that layer. And we can also look into the attention heads. And in models with having multiple attention heads, we can visualize the attention matrices for a selected layer. And this can help you understand how different attention heads specialize in capturing the different types of the relationships or the dependencies within that layer you're looking at. And this can provide you further insights into the model's ability to learn diverse aspects of the input data in the chosen layer. So if you think, that we are using multi-head attention because the human language is intricate and it has very nuanced ways of telling things. So for instance, if you have the sentence and you want to have a sentiment analysis on it, the movie was not bad. We as humans, we know that not bad actually classifies as positive. And the model uses then those multi-heads to be able to distinguish those nuances. And this is another example of attention visualization. And here we are visualizing the attention to token scores per layer. And this can help you in interpreting your model for the decision-making process to understand how the model processes the input and arrives at its outputs. And this can help you identify also potential issues or biases in the model's processing of the input data. And if you look at the token relationship and by examining the attention scores between those tokens, you can gain insights into which tokens the model considers relevant or related to one another. And this can help you understand how the model is learning and how it's capture syntactic or semantic dependencies also again between those tokens. And if you then look at the layer-wise evolution and visualize that attention scores per layer, this allows you to track how the model focuses on certain token relationships and how it changes, it processes the input throughout the subsequent layers. And here we look at the heat map, which visualizes the attention mechanisms context layer, which are used for a downstream task. And here the intensity of each cell in the matrix corresponds to the attention score for a respective token pair. And a higher score means that the model is paying more attention to that token pair. And by looking and analyzing such a heat map, you can gain more insights into how the model is making the decisions. And for example, you can see how the model is paying more attention to certain tokens or phrases. And this suggests that these parts of the input sequence are more important in making the prediction. And if the model is not attending to relevant tokens, it might indicate that the model is not adequately capturing the necessary information of your given task. And the attention patterns can also reveal whether the model is correctly capturing the relationships between words, such as syntactic or semantic dependencies. And this is actually the last slide on the attention visualization, and that kind of brings all together. So here we are looking at a visualization of the scores for all layers, and we examine here the distribution of this. And this can really help you in looking into the model's complexity. So if you visualize the scores for all layers, that can help you understand the complexity of the model. For instance, if you have a few layers that seem to be contributing significantly to the decision-making process, not significantly to the decision-making process, it might indicate that the model is too complex for a given task and a simpler architecture might be more appropriate. So if you're using that and if you're looking into that model deeper and analyzing in such a way, this can actually help you see if you need a different model, if the model is too complex, and that can at the end help you save you computational time and at the end also money. And we can look here at the layer-wise importance. And by comparing the intensity of the scores across different layers, you can identify which layers contribute more to the model's decision-making process. And that can help you understand how the model extracts and refines the information on that various stages. And also you can look at the distribution of the scores, and that can reveal patterns in how the model attends to different tokens. For example, the model might focus on certain parts of the input sequence or constantly ignore specific patterns. And if you analyze that, you can see, and that can help you identify potential issues or biases in the decision-making process of your model. So that brings me to the next part. And this is more about having a local explanation of your model. So with Line, you can explain individual predictions of your model. So Line provides a local explanation for specific instances of your prediction, rather than a global explanation of the whole model. So we had the layers and the attention scores we can look at, and now we are really focusing on just one prediction and one point. And it does so by approximating the complex model with a simpler interpretable model around the data point of interest, and you can actually select that. And about the importance of having such local explanations. So this can help users and developers understand how a model behaves for a specific input, and this makes it easier to trust and evaluate a model, and also for debugging purposes. And it also can reveal then the biases and inconsistencies in model predictions. And yeah, Line can be applied to large language models for tasks like text classification, sentiment analysis, or named entity recognition. And I have here an example for sentiment analysis. So what you are seeing here on the current slide is that we use here the pre-trained model to classify the sentiment of a sentence. Then the model gives us the logic for each class, which we then transform into the predicted label, positive or negative. And then we initialize Line with two classes, the negative and the positive. And then Line takes the instance you want to explain and generates a local explanation around it. And it does so by processing the text slightly many times and generates kind of a new data set around the neighborhood of the original text, and then makes the predictions for the processed data and for the points using the Distilberg model. And then, like I mentioned, it fits a simpler model like a linear regression and explains the prediction at that local region. And this is then how it looks like. So we see here that we get the local explanation of our sentence. So the text with the highlighted words is the explanation from Lime. This is actually the plot output. And we can see here that this movie was absolutely amazing, was correctly also indicated as positive. That gives us further insight how the model behaves. And here it's correctly behaving and classifying it as positive. And like I mentioned, this is really particularly useful for debugging or improving models and understanding their limitation and explaining their decisions also to stakeholders. And there's another point I really want to cover is about the Model Transparency Index, which was developed by the Stanford Center for Research on Foundation Models. And it's about foundation models like ChatGPT and so forth, because they are transforming society with their remarkable capabilities, but they are also containing serious risks. And because of that, the European Union is finalizing its AI Act as the world's first comprehensive regulation to govern AI. And they did that just 2 months ago. They adopted the draft of the act, and they had a vote of 499 in favor and a couple of against and a couple of abstentions. And the act includes explicit obligations to foundation model providers like OpenAI and Google. And what the Stanford Center for Research on Foundation Models did was they identified 22 requirements in that European Parliament draft of the AI Act that are directed towards foundation model providers. And they selected 12 of these 22 requirements and to evaluate, and they are also justifying that with why they excluded them, the remaining 10. And I added the link to their repository with all the explanations. So if you're interested in further information, make sure you check that out. And then they have designed a 5-point rubrics for each of those 12 requirements they selected. And then they selected 10 major foundation providers, like, for instance, OpenAI and Google, to assess, designating it to a flagship foundation model that kind of represents the provider for the purpose for the evaluation. And then they rated all 10 providers for the 12 requirements and produced then a final score. And I show these scores in an upcoming slide. And every underlying score comes again with an explanation and justification for the decision, and that is also transparent in their repository shared. And let me just quickly go over a few of the categories they are having. So they are looking into the data. So the copyright data, the data governance, they also look into the compute. So for the AI Act, the energy consumption is also important. And they look into the model specifically, so risk mitigations, the capabilities, how they are trained and tested. The deployment, so if you have a downstream documentation and how the member states are and the machine-generated content of it. And this is the slide I was mentioning. So here we see the overview of the grading of those foundation model providers and the compliance with the draft for the AI Act. And why I wanted to mention that explicitly is, so if you're considering for your organization to either via API use such a model or use an open source model and train it and use it for your organization, you might want to consider and look into that and see how they are, for instance, govern the data. So if you have data governance and they mitigate already biases, you don't have that extremely do it yourself. So that can actually help you in saving time, in having a better and non-biased model. And that brings me directly to the controlling of the generated content. And what issues do we have with uncontrolled generated content? So we have ethical concerns and potential for misuse, and we have challenges in content moderation. And one thing what we can do about it is we can monitor content generation. And how can we do that? So it's very easy. So there's a platform called Weights and Biases, and I'm sure lots of you already know that. And you can kind of track your experiments, you can log your models, you can really dive deep into how your model is behaving. You can see the GPU consumptions and more things. And you can also add with a few lines of code such tables, and you see what you put into the prompt for the model, and you see what it puts out. And let me make it a bit more concrete. So let me share you here the code. So I have here just different examples with different sampling methods, and these sampling methods are important to help the model or tell the model how creative it shall be with the text it generates. So this is a way we control the model's creativity, and there are different methods for that. And I track here just a couple of different ones, and I create different sentences, different outputs. And what I then do is with, like I said, just a couple of lines of code, you can add that tables, and you can log that to Weights and Biases, and you can access that. And this is then how it looks like. So it gets logged, and you see the different sampling methods. So you have the overview, and you see how the traffic is, the utilization. So you get different statistics as well, but you also see the prompt and how the text was generated. And you can use that for different generation tasks. And what is very helpful, what you then can do, you can create a report from that, and you can share that with your team. So you can use that for debugging your model, enhancing your model. And that is also one thing what OpenAI did. So they used, I know that they used that extensively in developing their models. So they logged and they produced reports and shared it with the team, and so enhanced their own models. So let me get back to the presentation, and let me hand over to my colleague, Miguel.
Okay. Let me see. Okay, good. It comes with a little bit of a delay, so just one sec. Okay.
Let me go back.
Yeah, okay. So thank you very much. Thanks, Nicole. So I see that there's a lot of comments and discussions in the chat, which is good, right? Obviously, what we wanted to say is that obviously all these topics are obviously very open to research and very open to new solutions, in the sense that bias, ethics, alignment, AI safety, right? These are transparency. These are things that are on the table for all the LLM, some sort of providers for the people that it's finally using LLMs, and obviously for the users, right? And is this by no means a really simple topic? So there's no magic recipe that will somehow get you to, oh, you know, all of a sudden, this is a very ethical machine. Ethics, fairness, transparency are obviously some sort of loosely defined topics, but we think that combining the tools we're showing here, right, with your specific user cases, your specific domain of applications, is where you know, things need to be, right? So I'm going to discuss briefly a few aspects that help and other LLM to somehow make these LLMs less raw, so to speak. The LLMs have read a huge amount of text. The text is highly biased, right? And how we can make sure that my son, my daughter, which is the LLM, is actually some sort of you know, making or some sort of giving me answers that show much less rawness, so to speak. OpenAI, right, surprised, I guess, everybody with a really, I would say, fantastic piece of computer science development, which is the reinforcement learning for human feedback, right? And if we, let me see if I can, okay, yeah. So the idea of, and I guess everybody in the audience more or less knows about it, it's like, how can we guide the model to provide some sort of answers that are more aligned to what users are expecting. So alignment is by no means, again, an easy topic, right? So should the answer be aligned to a PhD student? And should the answer align to, you know, somebody, right, that it's in high school, right? Should the answer be from a scientist, a highly technical? So the idea is we want, and also values. So it's not only content, but it's also values. So the way this was some sort of manufactured by OpenAI was, okay, so let's try to give human feedback, right? And use a very clever reinforcement learning model, right, to make use of this feedback to then some sort of produced more aligned answers, right? So the idea is, again, from reinforcement learning from human feedback, is better alignment with human values, improve performance, right? Also mistakes, right? Adaptability. So the idea is, can we do sort of 2 shots, 3 shots, even 1 shot easier, right? Because the machine is some sort of more aware of the human, let's say, values, preferences. Even the whole concept of alignment is not an easy concept. I think that this is really good solution. So let me spend, so what's an RL model? It's obviously about having an algorithm, an environment, right? From the environment, we take observations, the algorithm does actions, and then the way this is you know, this model is manufactured is, you know, there's a bunch of humans giving feedback. So the reward is coming from humans directly, instead of having a value function or an estimated, Q function. What is done is, right, there's a bunch of humans that gave feedback. Is this a good answer to the problem I've just asked? Is this a good, or this is a terribly bad answer, and you should modify the answer, right? So, and technically, the way this was done, right? Let me see if I can, yeah, 1 sec. This is, I need to go on.
You want to go back or forth?
More, yeah, or yeah, 1 more, right? Sorry about that. It's just, I don't know.
No worries.
Okay, yeah. So so this was a technical, right, implementation. So it's using PPO, proximal policy optimization, which is an idea of updating the policies, right? Having some not so abrupt policy changes, right? And you know, the reward, as I said, is produced by humans. So the humans produced a ranked, right, and say it's relatively low, and so on and so forth. And then again, this is fed back to the model. The model learns to optimize rewards, learns to somehow adapt to this human alignment. And this has proven to be some sort of a really nice way to scale, right? And to some sort of make some sort of a more of a a large-scale implementation, right? In terms of obviously, one might say, right, that the output's going to still be it's still be very dependent on the human feedback. So the choice of the evaluators is actually crucial here, right? And so on. But this is a really nice technical solution in order to, again, produce a way to give feedback and then the model some sort of have a natural way to produce its answers, right? Obviously, if we can go one slide more. Sorry about that. Yeah. Okay. So other ways in which we can some sort of obviously modify the outputs of such an LLM, it's penalizing tokens. So if you go one slide more, so the idea is simple, right? The idea is we want to just, for example, prevent model from generating harmful, offensive, or biased content. So you obviously don't want the model to be using several words. So you can put together a dictionary or keyword or several keywords in which you don't want the model to use, like offensive words, like the ones that come to our mind when we want to offend and so on, or slurs, or misdemeaning behavior, and so on and so forth. So this is an obvious manner in which, and obviously this is something that it was already in all sorts of other chatbots and so on. You don't want them to use several specific words. If you want one more, okay, so this the ways you can do word lists, which I have to say it's pretty some sort of useful in the sense that you get at least rid of the most evident cases, right, of using words, right? You don't want the LLM to be some sort of talking rude to one of the users, right? So you can actually some sort of say I'm penalized, right? So when I have the final softmax layer with the probabilities of every token, so you just say these words are never to be used with high probability, right? We don't want these, even if, for example, the user wants to use it in a specific context, or context-based penalization. Some words can be penalized in a specific context, right? So this gets you pretty far in terms of AI safety, in the sense that at least you make sure the most evident cases, your LLM it's not a very rude LLM, or it's not a very offensive LLM. It's not using, right, specific words. So we've gone one more. So, right, so this is how you would do it, right? So we penalize certain words, prohibit the words, stupid, lazy, dumb. So we don't want the machine to be using that, and obviously generate a context. So one might say that there's several ways to crack these and so on, but the first layer of AI safety should be penalizing tokens. So not allowing, like the same way we do with humans. We don't want our salespeople, we don't want our kids to use certain words in any specific context, and some other words in some other context too. So we spend a lot of time, right, doing that. Okay, so this is a pretty evident way to do it. So let's go ahead. Thank you. Okay, one other way, it's obviously prompt engineering, right? So when we go one more. Okay, so we identify a limited set of high priority keywords of topics, and we create specific prompt engineering rules for them, right? Again, it's hard to be, right, maybe before even discussing this, right? So it's very important what I said before. It's very important that for your specific domain of applications, you just test the element, right? For example, if you're doing healthcare, if you're doing finance, right? Finance, for example, it's, transparency and interpretability is required, right, by US regulators. But also it's required to be non-discriminative, non-biased, and the products to be suitable, right? Just as a right. So, and it's not only that we want a well-behaved machine. So we have certain law obligations, certain regulatory obligations, and we want to make sure that So pattern matching, right, is one potential way to influence, so to speak, the outcome of the LLM, right, using prompt engineering, right? So we use regular expressions and other techniques to identify patterns in user inputs and modify these prompts accordingly, right? Then the next one, we use machine learning, right? Classifies to categorize user inputs into predefined categories and apply prompt engineering to these ones. Next, we provide a nice example of a very evident one, which is in many contexts, like for example, right, finance, your do not have a license to give investment advice. So you should be very clear with all the users. This is not considered. I'm not a financial advisor. I'm not I'm not a professional doctor. I'm not your therapist. So whatever I'm giving you is some sort of a general advice, right? You should consult to an expert that has a license, for example. So this obviously has legal implications, right, for OpenAI, for everybody. You don't have the license to do some stuff, right? So adding a disclaimer is really easy to do. Here we see an example, right? So we can add easily a disclaimer. So when the topic is discussed, like investing, stocks, financial portfolio, so please add this disclaimer. When we discussed about, again, healthcare, you have to say, I'm not a doctor. This constitutes by any means some sort of healthcare advice. Okay, so if we move on, right? Okay, what about bias, fairness, ethics, and so on, which is right? Obviously, here there's no magic cure, or there's no magic recipe in order to avoid bias, right? But I think that we can agree that the different set of ideas that we present here, right, are really common sense, right? This is really how. Before AI, by the way, we were required to offer, right, non-biased, non-discriminative behavior, right? So these rules in the United States, for example, the suitability of financial products have been out there, right, for decades, right? So we were already, right, trying to comply with the idea things to be transparent, things to be somehow, and we need to mitigate bias. Right. So obviously, right, one might say, right, and we often hear out there, right, the idea of my SBMs, my transforms are not biased, so I don't need to care about all these things, right? Obviously, this is not true, right? Obviously, where a responsible AI scientist or responsible AI user, right, needs to make sure of the outputs of the model, right? So finally, AI is a tool, right, and we need to make good use of it, right? And again, you might argue your transformer is not racist, your transformer is not sexist, or your SBM, your super vector machine. But in the end, it's the combination of data sets and algorithms that produce an outcome, and we need to make sure that the outcome is somehow biased and fair and so on, right? So obviously, one way to do it is generating a diverse data set, right, which is which is oftentimes not possible, I have to say. Oftentimes you have data sets that basically inherit a bunch of so sometimes minorities are not well represented, sometimes minority, and this is obviously right. The fact of the previous models were heavily biased. So AI, the bias is not coming here just because AI, right? Bias has been with us so it has been for us for, I would say, all of human history, right? So AI is not bringing, right? But obviously, again, so how can we try to alleviate the problem, right? Data diversity, right, is so collecting diverse and representative data. So we need to be sourcing data for a wide range of sources and domains, ensure data collection includes underrepresented or minority perspective. This is a really very tricky topic, right? But because again, your data sets do not have lots of examples of that, right? So, and again, you can't blame the algorithms, you have to blame the whole system, but we're here to solve problems, right? And to try to improve, society, so to speak, if that's okay. And obviously then incorporating feedback, it's always important. So do I think that the different stakeholders with the output of the model feel represented, feel that the model is giving some sort of fair outcomes, right? Fairness is not a mathematical equation. Fairness, will show several mathematical techniques or statistical techniques to make sure that on the surface things at least do not seem to be heavily biased. But again, incorporated feedback might be one of the most important ones, right? Obviously, feedback from diverse set of users, not just, again, back to the biased some sort of way in which we were managing all models, right? And then continuously monitoring and updating the data set to reflect evolving language and societal norms, right? So let's move on. Okay, so how we can detect bias. So we have several fairness adjustments, right, that we can make to model outputs, right? And all of them make kind of a lot of sense to even a non some sort of AI expert or let's say on non-fairness expert, right? Which is Aldea. If that, can we observe that the model preserves some sort of statistical parity difference, right? So statistical parity difference is one way to look at the problem, right? If we don't observe statistical parity, this might mean that probably our model is based in terms of gender, sex, or age, or race, and so on. Equalized odds processing, reject option classification, calibrated equalized odds, which is some example that we're gonna show in a minute. So one way to look at the problem, so we put together here, we ask an LLM to classify textual context based on the perceived age of the author from their writing style, right? And the sensitive feature is age here. So we want to make sure is if somehow, right, again, the LLM is being, right, is having some sort of an age bias, and the way we can test that, right, if we go one slide more, is by using statistical parity difference, right? It detects potential biases in decisions, especially crucial for impactful real-world applications. Basically, it's about measuring the difference in favorable outcomes between privileged and unprivileged groups, right? So the idea is that if there's zero, so there's no discrepancy, all groups seem to have somehow the same favorable outcomes, or the same level of unfavorable outcomes, it might tell you if the model seems to be treating fairly the different groups, right? Okay, so, right, being, and an example here, it's about, we pick a review of movies. I love the movie was terrible, one of the best movies ever, and so on, the ages, right? And then we go to Hugging Face, and we use sentiment analysis from Hugging Face, and then if you want like more, we can conclude, for example, in this very simple example, that it seems like, right, if the statistical parity difference is -1, it might indicate that it has a strong age-related bias, right? Okay, again, right, this is not only things you can do with LLMs, you can do literally with any of your existing, not only AI models, but any model, right? Banks have credit models that are not based on AI, that are based on maybe simpler algorithms that they have a huge amount of bias inherited from the data set, right? Inherited from the fact that these minorities are underrepresented, and you haven't probably done any of these checks. So I think it's interesting for data scientists in the room, right, to be aware of these are tests that you can actually perform. Another, obviously fairness, right? One specific sensitive topic, it's about credit approval, right? So can we some sort of look at an LLM, right, trained to predict credit approval decisions, right, based on various features as income, employment status, and age, right? And the sensitive feature here is going to be the gender, and it's going to be, so we're going to have here 200 samples. Okay, so equalized odds pre-processing, right? So here we see the confusion matrix, right? So here the idea is that you want to make sure that false positives and false negatives somehow, some sort of at a reasonable low level for both genders, right? Or for all the genders in the data set, right? So before the adjustment, for example, in which we force the model to have equalized odds, right? We have for men, 49 false positives for women. After applying equalized odds pre-processing, right, post-processing, sorry, the false negative rate for men is reduced to 43, and the false positive for women is reduced to 48, right? So again, false positives are for or false negatives for everybody, but you need to also make sure that are at least not discriminatory, and you don't have such discrepancies between the different genders. This is not the only some sort of, you can do reject option classification, again, which is another way in which you can some sort of to a certain extent fine-tune the model in order to produce a more some sort of fair outcome. So before the adjustment, right, the model has 50 false negatives for men, 49 positives, false positives for women. And when we apply reject option classification, the false negative for men is reduced to 42, and the false positive for women remains at the same 49. So it's slight adjustment. We probably need to do even more work, right? Obviously, right? Okay. Again, right, just again as a disclaimer, right, these are not by any means perfect models in the sense that you might say that this is some sort of very raw, but you have to be applying crowd-related equalized odds or statistical parity and so on in the issues that you consider especially sensitive in your domain of application. So that's why there's no general receipt, but this provides you a way to compare stuff, right? To compare among the different groups. You want to make the thing somehow fair, and so on and so forth. So in terms of using calibrated equalized odds, which is the fourth technology we wanted to talk about, before the adjustment, again, we have these 50 false negatives, 49 false positives, and the false negative rate for men, it's reduced to 41. The false positive rate for women remains at the same 49. Again, you probably need to tweak even more the model, right? In order, but again, this is just an illustrative example of different, some sort of at least, right? Okay. Next. So in conclusion, right? So all these matters that we've discussed here, right, are extremely important for LLMs, right? Certainly LLMs have brought to us, right, an incredible amount of, new applications, right? And they're incredibly useful for things like obviously coding, right? Or when we write papers, right? Or when we look at different data sets and so on. So it's obviously crucial that all these ethics, safety, fairness, transparency, right, is as we said along the presentation, this is not an easy topic that we can actually click and now all of a sudden the model will behave as a safe and ethical some sort of computational being, right? So this is a multi-layered aspect. This is a very subjective topic. So everybody here has a definition of what's the alignment of a question about even technical aspects, right? So even if we ask a question about, do you think the future of neural network architecture are transformers, and maybe we have in the room 50 different opinions of what's the right way to answer that question, right? And this is just a technical question, right? So ethics is also a multi-layer aspect, right? In which what might seem ethical for a person might not seem ethical for another, right? But and obviously safety, right? Safety in terms of not allowing the machine to help us build bombs, not allowing the machine to help us harass our neighbor, and all these kind of stuff, right? So And then obviously, right, striving for a future with ethical and safe AI systems, right, I think should be the ultimate goal for all of us when we develop our models, right? For researchers, practitioners in LLM, right? Obviously in the EU AI Act, so there's quite a lot of these, right? There's quite a lot of, for example, again, in the financial domain, there's a lot of already regulation, not only binding AI models, but all sorts of models that you use, right, for credit should be aligned, should be try to be not, right? Okay, so yeah, and I see a lot of excitement in the chat, right? And I hope that now we can have a very interesting discussion. Here we have the reference, and thanks for your attention, right? And
Okay.
yeah.
I'd like to thank you, Nicole and Michael, for this interesting talk. It's a very new topic, so there are many questions. We had 40 questions, and we can address some of them. The first one is there a, sorry, how do you deal with biases of the people who train data? Models can figure out this kind of biases. And there are also two related questions. Has anyone thought about how to measure unconsciousness bias in models? And another people asked, was wondering what kind of bias might occur involving age.
If I may,
Sure.
So the first question is this again a very, right? You know, some people have said, for example, right, how can we avoid political bias? So political bias is something really sensitive in the United States, right? Because it's saying, okay, is the machine right or left? Is the machine somehow discriminating differently, right? And the reality is probably that it is, right? That probably, right? If you ask the machine about Trump and you ask the machine about Biden, and then you try to somehow, for example, do sentiment analysis, right? On the top of that, right? You'll probably, you know, see that the machine inherits some of what it's reading in the press, that it might be biased, right? And obviously you're not a political, right? So this is a very sensitive topic in the sense how can then you modify this, right? And maybe you can some sort of, when you talk about gender, politics, and you need to create very neutral answers instead of what it has read, right? It needs to provide really very neutral answers saying, you know, this person, it has a specific, or this work has a specific gender or not. You see what I mean, right? So you need the machine to produce more gender neutral outcomes, more race neutral outcomes, more politic neutral outcomes. You probably can do that using reinforcement learning for human feedback, like saying, no, I want you to be somehow less biased, so I want you to produce some sort of an answer. And some people obviously complains about that, because then the machine is providing like a very boring answers, like all of them are great people.
Yes.
But yeah, and you can actually use, if you use a reject objection classification for your model, you can see if you have bias in your model. So just to answer that question about how to deal with that, so you can use that and then use what Miguel just said. You use that reinforcement learning from human feedback, and then you can help your model to mitigate the bias. And of course, if you feed biased data into your model, you will always receive a biased outcome. So you as the machine learning engineer, data scientist, or developer of that model, you need to make sure that your data is non-biased and includes all of the parties which are related. So the minorities and so forth, and not strong opinions.
Yes, it's also a data quality problem in this case.
Exactly.
Yes.
Well, obviously the data doesn't have an obligation to be fair, right? So
yes,
so we cannot live under delusion that what the machine is going to read is some sort of fair, ethical stuff. It's going to read all sorts of different stuff that it's out there.
yes, and there is just a question about fairness. How do you define fairness for this type of system? And also some related questions. There is not just one set of agreed on human values. How do LLMs deal with this in RLHF? And also whose values, which culture, and who gets to decide in this RLHF scenario?
Yes, so the diversity of the evaluators in the RLHF is a source of obviously controversy, right? I think that in the end, as usual, right, what is going to provide more diverse outcomes is if you engage with more diverse set of evaluators. If you have evaluators that have some political views, right, they might distort further the machine into some sort of opinion or not, right? But again, there's ways in which I think here we have presented ways in which if you see that consistently the machine is giving favorable opinions about a specific party instead of another, right? This is something you can also try to modify, right? And try to tweak, right? For example, when we were doing sentiment classification or sentiment, which is a regression, right? And for example, the machine was saying, you know, if I am a German car company that in the past did something bizarre with diesel emissions and so on, I probably will not have a very good reputation, and all my sentiment is going to be negative. So to what extent should we neutralize these kind of things, or a specific person that has done this and that, right? And the sentiment, the machine, right? Or a specific politician that has done this and that. So this is a multi-layered, right? And somebody was asking about ethics. So ethics should be, there's no general definitions for the problem you're trying to solve. You're trying to make sure that for the specific problems that you're trying to solve, you need to test to what extent the outcome is biased or not. There's no guarantee that it will not be, right? We have no guarantees that
Yes.
because but it's not OpenAI's fault. It's because you cannot. So bias can exist in the model. Bias exists in any model, right? Let's us be clear with that. So bias exists in any model, right? In any model that you have it writing, right? Maybe the model has a preference for, I don't know, German poets instead of Italian poets. And all of a sudden you say, why the model is so, I don't know, right? So it has read this and that, and it seems to, you see what I mean, right? So we have no guarantee
Yes. Yes, great.
So yeah, and just to answer from a different point. So from the development point, I would also say it goes with the feedback the same way with having the diverse data. So you need the diverse feedback, and you make sure with that that you have it, and this should comply with the compliance of the company. So the fairness will be defined for the company, like Miguel just said. So one company has other rules and some has different ones. So this is a reason why we had those different stages. So you might be a lawyer and there are certain things you can't say in the chat or whatever, and that needs to comply with your company.
Yes, there is also another question related to bias. In this context, what is your opinion on multidisciplinary cooperation to mitigate such biases? And do you consider it important to establish multidisciplinary mechanisms that constantly update bias mitigation monitoring measures?
Yeah, of course, right?
Yeah, definitely, right? Yeah, go ahead. You want?
No, what I'm
Okay.
So I think
Yes.
bias you can even try to, right? Again, for example, one thing you could do, right, is like, okay, you ask the LLM to produce opinions on genders, right, for different topics, right? So you're very open, right? And you measure sentiment on them. If you think that this is discrepancy in terms of, again, model being, somehow using more positive sentiment for, or more positive sentiment for a nationality compared to another, and all that kind of stuff, you can even but this is a very multi-layered topic, that ethics is not only about, nationalities or genders. This is a multi-layered concept, but there's some sort of, I think there's a little bit of science you can do, right, on it, to make sure that again, right, it's not using more demeaning words when it speaks about a specific gender. It eventually will, because maybe the human feedback hasn't, right, been able to, right, again here, right, so that's why you need to make lots of different check layers.
Yes, here in the Q&A chat, there is a live conversation about bias, but I'd like to ask another question if we have time, which is another topic. Just a moment that I lost it. And it was, okay, this one. LLM has that ingurgitate a large amount of data, has the potential of linking anonymized data. So the topic is about data anonymization to produce personal identifiable information. Are there tools, methods that would help safeguard the release of this information? If not, how should LLM be considered in the context of ethical considerations related to human subject research? It's a complementary topic respect to bias.
Yeah, it is, and there are tools. I don't know the library right now. If yeah, just send me a message on LinkedIn. The ones are interested in this, and I will forward you the library. But there are tools that helps you do exactly that with your data and control that more. So yeah, there are ways of doing that.
Yes, let's move to another question. These models are mostly English-based. What are the challenges to expanding to other languages?
That's a good question, right? So I speak several languages, and I have to say that when I'm trying, for example, right, English and Spanish is excellent. I cannot say that at least GPT-4 is bad, or it's Spanish is also really good, right? French is pretty good, right? Catalan is pretty good. My Chinese friends, though, say that Chinese GPT-4 language skills are not maybe so brilliant than in others. I don't know if that relates to the fact that Chinese is a really multi-layered and so on and so forth, right? But obviously, right, if we cannot, right, so English language has a huge amount of text to read. Minority language do not have that, right? So you cannot expect that you will have in, I don't know, for example, in my native language, in Catalan, you cannot expect to have the same amount of English, or for example, of research papers, right, or anything like that. So it wouldn't be like the way to go to just to train the LLM in your language and say this is it, right? I think to some extent it's needed. one really interesting aspect here is that this provides, I think, and this is coming from my NLP background, or what we see, this is really a good opportunity for minority languages to have a much larger corpus of language, right? In the sense that you can artificially generate, right, very good minority language text that can be then corrected by let's say natives, right? But it gives the opportunity, I guess, to minority even to survive, right? In a world in which a little the production of stuff, I don't know, I'm inventing in some language in a region of China is just very small, right? So this provides the opportunity to this language actually to survive, right?
Right.
Obviously, translations are not perfect, but they're pretty good.
Yes.
Yeah, and there are actually a couple of models which are incorporating that. So there are large language models specifically doing this. And for anyone interested, so I shared the link from the books repo. I have a couple of models in, I think it's chapter 3 or 4, it should be 4, about language translation. And there are techniques how you have or how you can apply the model then and learn a minority language much easier, because the model already is trained with 100 of languages, of diverse languages, and because of that it knows different patterns and it learns easier. And as Miguel just mentioned, for but other extremely large foundational models, they are trained of a diverse set of different languages already as well.
Okay, the list of questions is very long and interesting, and I think that the conversation should continue, but I'm afraid we have run out of time today, and I'd like to thank Nicole and Michael again for their informative presentation and insightful answers to the many questions. A special thanks to each of you for taking the time to attend and participate today. This talk was recorded and will be available online in a few days at learning.acm.org. You can find an announcement on upcoming talks and other ACM activities at learning.acm.org and acm.org. Also, please fill out our quick survey where you can suggest future topics or speakers, which you should see on your screen in a moment. On behalf of ACM, Nicole Kunstein, Michael Noguera Alonso, and myself, Angelica Loduca, thanks again for joining us, and I hope you will join us again in the future. This concludes the talk.